Welcome back to lecture number 9 on unit number 1, properties of fluid. This lecture we are going to discuss the numerical part of surface tension. Surface tension concept we already learned in previous lecture. So as far as the numerical part is concerned, you have to memorize the three expressions. That is the excess pressure in case of liquid droplet, excess pressure in case of soap bubble, and excess pressure in case of liquid jet. So one way of memorizing these expressions, so especially you have to remember the expression of liquid jet, that is the lowest pressure we can say. And it is always convenient to memorize the expression in terms of diameter rather than in radius, because most of the problem statement, the diameters are given. So for example, for liquid jet, it is 2 sigma by d. For droplet, that is liquid droplet, it is 4 sigma by d. And for soap bubble, it is 8 sigma by d. So only that the coefficient, that is 2, 4, and 6. Remaining expressions are same. So these expressions you have to memorize for solving example. But only memorizing the expression is not sufficient for solving problem. You should understand the interpretation of the problem, statement of the problem, and accordingly the suitable expressions to be used. So one by one we'll see the numericals. So the first numerical, a glass tube of internal diameter 2 mm is partially dipped in glycerin with its lower end 20 mm deep. So this H is given, that is 20 mm deep below the surface. So this is a glass tube. It is partially dipped in glycerin. So this portion is filled with the glycerin, the container containing glycerin, and the glass tube obviously open at both ends. It is partially dipped in glycerin, and its depth is given, that is H is equal to 20 mm. Air is blown into the glass tube. So air is blown into the glass tube so as to form an air bubble at its bottom end of the dia of tube. So the diameter of the air bubble is equal to the diameter of the tube. So the bubble is formed inside the liquid body, that is in the glycerin. If the specific weight and surface tension of glycerin is given, that is 12.356 kilonewton per meter cube, and the surface tension is given, that is 0.0637 Newton meter. Find the pressure of the air blown. So this is a problem statement. So it seems the problem that bubble is formed inside the liquid body. So we see everyone use the expression of bubble as the bubble term is mentioned here, but you have to see the situation as well. So bubble expression is developed considering that bubble is formed in the air. So if the bubble is formed in the air, there is air present outside the bubble surface as well as inside the bubble surface. So that's why two values of sigma are given. But in this particular situation, the bubble is formed inside the liquid body. So inside the liquid body, the bubble is formed. So that's why of diameter d. So if it is formed inside the liquid body, so there is only one surface associated with air, that is inside. Outer surface that is in contact with the glycerin. So there is only one sigma which keeps the bubble in equilibrium, not two sigma value or not two surfaces are present. There is only one surface which comes in contact with the air. So we have to use the expression of liquid droplet rather than the expression of bubble. So even the term air bubble is mentioned, but we cannot use air bubble expression here. The reason why? Because in bubble expression, there are two surfaces are associated with air, outer surface as well as inner surface. So in this case, only the inner surface is in associated with the air. Outer surface is in associated with the glycerin. So we have to use the expression of liquid droplet. So according to that, the given quantities, if you see, the diameter of the tube is given, same is the diameter of the bubble. So that is these 2 mm. H height is given, gamma value, that is specific weight, is given, and sigma is surface tension values given. So what excess pressure is required? So first, the pressure required in excess of atmosphere. So atmospheric pressure here, so the pressure surrounding the bubble is not atmospheric pressure, because this bubble is formed at some distance from the free liquid surface. So here pressure is obviously in excess of atmosphere. So that is because of as per the hydrostatic law. So that hydrostatic law uh, we, we can study in unit number 2. But right now you have to just take that particular expression of hydrostatic law, that is gamma into H. So that is the pressure in surrounding, and the pressure required to form the bubble, that is excess pressure. So total pressure is the addition of these. So the pressure required to form the bubble, as the bubble is even it is bubble, we have to use the expression of liquid droplet, that is 4 sigma by d. And so it comes around because both sigma and d values are given, that is 127.4 Newton per meter square. This is not the final answer, because this is only the pressure required to form the bubble in the or liquid droplet in the air. But here it is formed inside the liquid body. So first of all, some pressure is required to overcome the pressure of the surrounding. So that pressure we can calculate, that is gamma into H. So total pressure is PB plus gamma into H, and it comes around 376.52 Newton per meter square. So this is the final answer. So this way you need to understand the statement properly, and the interpretation of statement is the key for solving problem in case of surface tension. This is problem number 1. In the second problem, so there is a pinhole 0.1 mm in diameter at the bottom of the vessel. So this is a vessel containing some mercury, and the height of that particular liquid level, that is mercury level, is given from the bottom. And there is a hole of 0.1 meter, so diameter 0.1 meter is given. What depth of mercury can be put in the vessel without any leak occurring? So sigma value is given, that is 0.5 Newton per meter. So again, in this case, we have to calculate the pressure required, or the minimum pressure required to overcome, so that the leak will start. So leak will start if the pressure exceeds the pressure required for the bubble. So whatever the pressure required to form that liquid droplet, same is the pressure required, and that pressure later on we can calculate, convert into the pressure head. So this is nothing but pressure head. So again, in this case, the pressure required to form the bubble, that is equal to whatever the pressure at this particular point. So if that pressure is overcome, then obviously that that leak starts. So that is interpretation. So PB, that is equal to gamma H into 4 sigma into D divided by D. So H is equal to 4 sigma. So H is equal to 15 mm. That means if the pressure is in excess of 15 mm, so if the height level exceeds 15 mm, then leak starts. So till if it is less than that, there is no possibility of leakage. So this is the minimum depth, that is the maximum depth we can say. If it exceeds that particular, if H exceeds that amount, then obviously the diameter H is increased. So diameter, if H is increased, the diameter is reduced, and obviously the leak starts. So till 0.1 mm dia of the liquid droplet. So in order to form 1 mm dia liquid droplet, this much pressure is required. So that is pressure head. This is nothing but pressure head. So if it exceeds that, definitely if we see this, if it exceeds that, diameter is equal to 4 sigma by, if it exceeds the diameter is less than 0.1 mm, and the leak starts. So this is the interpretation of the problem. So such kind of problems can be asked generally for the GATE examinations. So the GATE examination is very difficult to recognize the problem, but here you can easily recognize. So interpretation is required. If it exceeds that, then it starts leaking. So this is the interpretation. So this is problem number 2. Then the third, calculate the work done in blowing soap bubble of diameter 100 mm. So soap double bubble is to be formed. So what work is required? So I'll assume that the surface tension of the soap bubble is given. So this is straightforward soap bubble formula. But here, what is asked, that is work done. Work done is the force into distance, or in this case, it is surface tension into area. So diameter is given, 100 mm. Sigma value is given. The soap bubble has a twice interface. So the work done, that is equal to surface tension into area, because the expression of work, that is force into displacement, so Newton per meter. So if surface tension is actually a Newton per meter, multiply by meter square, it is Newton meter. So there are two surfaces of soap bubble, so the which are formed uh, because it is formed in the air. So 2 sigma into area of the sphere, that is 4 pi r square. So that comes around, this is the work. So this much work is required to form the bubble. Or if the pressure is asked, so the formula of bubble is 8 sigma by d or 4 sigma by r. So that formula we can use. Then the next expression, next problem statement, that is in order to form a stream of bubbles, air is introduced through the nozzle into the tank of water at 20 degrees Celsius. If the process requires 3-meter diameter bubbles to be formed, by how much air pressure at the nozzle must exceed that of the surrounding air? What would be the absolute pressure inside the bubble if the surrounding water is at 100 kilopascal? Surface tension value is given. So diameter of the bubble, that is 3 mm. Then surface tension of water at 20 degrees Celsius, it is given. The excess pressure intensity of air over that of surrounding water, that is P. Delta P is equal to P. So that P we can calculate by using again the expression of again this particular soap bubble is formed inside the water body, because it is formed in this similar kind of problem. So again the expression of liquid droplet is to be used. So this is actually the excess pressure, that is 98 Newton per meter square, but the surrounding water is at just above atmospheric, that is 100 kilopascal, here 100.3. So in that case, in order to calculate absolute pressure, we need to add that surrounding atmospheric pressure. So PB plus atmospheric pressure, that is 100.398 kilonewton per meter square. So absolute pressure required, that is plus, because absolute pressure is atmospheric pressure plus the required pressure in this case. So again, in this case, like first problem, here still the bubble is formed, but again the bubble is formed inside the water body. So if it is formed inside the water body, we have to use the expression of liquid droplet. So accordingly, the liquid droplet expression is used. So the answer is 100. So that's it from this lecture. So at the end of this particular lecture, we should be able to apply the suitable expression of surface tension to solve the engineering problems. Maybe most of the problems are can be a practical one. Formation of bubble, work done, then the leakages. So there also the expressions are used. So most of the case, the selection of key of the solving problem or skill is the selection of suitable expression. Especially there is confusion arises in the expression of soap bubble and liquid droplet. The soap bubble expression can only be used if the bubble is formed in the air, not in any liquid body. So if it is formed inside the liquid body, then we have to use the expression of liquid droplet. With this, we have completed the numerical part of the surface tension. As far as this numerical can be asked for generally for 2 to 4 marks, not much to weightage, but most of the gate examination you find such kind of numericals. So the difficulty levels are slightly high. That's it. Thank you very much.